Welcome back. In this video, I will go over general approaches to catch reconstruction by sector. After checking the reported baseline, I've been identifying which components of the data are missing and therefore need to be estimated using the information I have gathered. One way I can go about this is to estimate total catch using a measure like the catch per boat per year or the catch per fisher per year and multiply this by the number of boats or fishers operating within that year. This will give me the total catch for a sector or a fishery. It may also be that, in my research, I find total catch for a given year for a specific fishery or sector. In both cases, I can subtract the reported baseline catch from the total catch and the remainder would be the unreported component. In the case of Olalan, I had access to the number of artisanal vessels catching groupers and the average catch per year per vessel, which allowed me to estimate the total artisanal catch of groupers for 2022. I then subtracted the FAO reported catch from the estimated total catch to get the unreported catch amount. The calculations look like this. If total catch equals the number of vessels by the average catch per vessel per year, then the total catch is 27 boats by 19.9 tons, which equals 537.3 tons. Then, if the unreported catch is the total catch minus the reported catch, I subsequently subtracted the 300 tons of catch reported by the FAO from the 537.3 tons of total catch I previously calculated, which gives me a total of 237.3 tons of unreported catch. It is also possible to estimate the unreported component as a ratio of the reported catch. For example, I found that in Olalan, for every 5 tons of shrimp that is caught, there is 1 ton of shrimp catches that were not reported. I then used this ratio to calculate the unreported shrimp catches for 2011 to 2022. So, in 2022, the unreported catch was determined by multiplying the reported catch by 20%. In other words, 11,551.69 tons by 20% equals 2,310.33 tons. If in the literature I find that the reporting system of a fishery only represents a certain percentage of the total catch, then I can apply this percentage to get to the unreported component. For example, through my literature search, I discovered that Indian mackerel tends to be underreported by 15%, meaning that reported catch only accounts for 85% of the total catch. I used this information to estimate the total catch of Indian mackerel and subtract the reported amount to get the unreported catch amount. I'll explain this with numbers. For 2022, I used the formula total catch equals 100 over 85 times reported catch. In other words, total catch equals 100 over 85 times 350 tons equals 411.76 tons. On the other hand, the formula for unreported catch is total catch minus reported catch. For 2022, the unreported catch was estimated by subtracting 411.765 tons minus 350 tons, which equaled 61.765 tons. For the industrial sector of Olalan, I will note that this is the sector with more reported data because the catch of large commercial vessels tends to be closely monitored given that they pay high taxes and export fees. Often, national data are better disaggregated by species, so it is possible to obtain the unreported component of the industrial catch by subtracting the FAO reported catch for a taxon from the total catch for that taxon reported nationally as caught by industrial gears. For example, I compared the national and FAO data for Olalan's yellowfish tuna catches from 2011 to 2022 and found that the FAO data are lower than national data as catches by semi-industrial gears were not included in the FAO data. If in the literature I find information on catch per unit effort, CPUE, of an industrial gear deployed in the EEZ of my country, I can multiply this metric by the number of actively operating industrial vessels deploying this gear in the EEZ. This will give me the total catch. I can then compare this CPUE-based total catch with the reported catch. If the CPUE-based total catch is higher than the reported catch, then I can identify the difference as the unreported catch taken inside the EEZ. If the reported catch is higher than the CPUE-based total catch, then this difference is assumed to be caught outside of the EEZ. One key consideration when assessing industrial fisheries is that, for the sea around us, all fishing occurring outside a country's home EEZ is considered industrial, regardless of boat size or the national definition of the sector. This also means that catches taken by Olaland's fleets in neighboring countries, which would still be reported as happening within the same FAO statistical area, will have to be assigned to the respective EEZ based on access agreement information or other relevant data. It is also crucial to be aware that all gears that are dragged or towed across the seafloor or intensively through the water column using engine power, no matter the size of the vessel, are considered industrial. This means that the large motorized pirogues operating within the EEZ of Olaland are industrial, as are baby trawls and midwater trawls. Industrial fisheries are, in general, the main source of discards. Thus, for all countries and territories, the sea around us accounts for two types of catches, that is, landings, which are catches retained on board and landed, and discards, which are non-target fish and invertebrates caught, also called bycatch, and then thrown back into the ocean and assumed to be dead. This will include catch of animals that are below the allowed minimum size for the species and catch in excess of the total allowable catch. This type of discarding is common in managed fisheries in Europe and North America. As I mentioned before, in the case of Olaland, we know that shrimp fisheries normally retrieve about 2 tons of catch for every 1 ton of shrimp, and we also know that, on the average, about 30% of bottom trawls' total bycatch is discarded in recent years. Keep in mind, however, that discarding rates are dependent on the gear and target species. What I did in my reconstruction, thus, was first estimate the unreported component of shrimp fisheries, and once I added the total catch, I applied the discard rate of 27% that I found in my research to the total catch for 2011 to 2022. Here's the example for 2022. Based on our previous calculation, the unreported shrimp catch is 2,310.33 tons. If total catch equals reported catch plus unreported catch, this means that total catch is the sum of 11,551.63 tons plus 2,310.33 tons, that is 13,862.02 tons. Discards, on the other hand, are estimated by multiplying the discard rate by total catch. In this case, then discards are the product of 13,862.02 tons multiplied by 27%, which equals 3,742.74 tons. Since there are other types of industrial vessels operating in the EEZ of Olaland, I will have to find the discard rates for each type of fishing gear and make sure to determine whether these rates relate to target species data only, to landed catch only, or to total catch brought aboard before discarding. Now I will move on to reconstruct the artisanal catches of Olaland. The artisanal sector is the most likely small-scale sector to have reported data because its catch is predominantly sold commercially. Following the definition of the sea around us, artisanal fisheries are those who operate only in domestic waters and within the inshore fishing area. This means that they are limited to a maximum of 50 kilometers from the coast or to 200 meters in depth, whichever comes first. Artisanal vessels are smaller and less capital intensive than industrial vessels and mostly use passive gears such as handlines and gill nets or fixed gears like weirs or traps. In the case of Olalan, I found in my literature search that there is a 1 to 10 ratio of unreported catch to reported landings for snappers and job fishes caught using small-scale gill nets and cast nets, which I then applied to the 2022 reported amount to estimate unreported artisanal catches as follows. Unreported catch equals 10% by the reported catch. Thus, I multiplied 605 tons by 10%, which equals 60.5 tons of unreported catch. For crabs, I found in a report from the NGO Fishing for Food total catch landed by artisanal traps, which I later subtracted from FAO's reported catch for this taxon. Here, I'll show the calculation for 2011. If unreported catch equals the total catch from the Fishing for Food report minus the reported catch in FAO data, then 6.6 tons minus 4 tons equals 2.6 tons of unreported catch. One final option is to apply a catch per unit effort measure to the number of vessels or the number of fishers and associated effort measure, as I have shown earlier to calculate unreported catches for groupers. So, by multiplying the number of vessels by the average catch per vessel per year, I got total catch. For Olalan, I had 27 boats in 2022 and 19.9 tons of catch per vessel per year for a total catch of 537.3 tons. In the case of unreported catch, which is, once again, total catch minus reported catch, I subtracted the 300 tons of reported catch from the 537.3 tons of total catch, obtaining 237.3 tons of unreported catch. Thanks for watching. In the next video, we will go over the reconstruction of subsistence and recreational sectors. Stay tuned.